Khan Academy, we have a quiz on Saturday. It's on here. And it's up to the section, but not including the section called piecewise functions. Okay? I was going to give an in-class quiz today, but my other class I couldn't, teaching the same class on Monday, and I couldn't get into the computer room where I wanted to give the quiz, so I decided not to give the quiz this week. So next week we'll have an in-class quiz. Next week means next Tuesday we'll have an in-class quiz, but actually we have an in-class quiz on Khan Academy on Saturday. So that's here. Okay, and I explained all this in the videos, so you can go and check if you missed the class last time. Makeup class is here. It's period 4, IPS 1. I think that's in the other building. Okay. And tutorial sessions. So for this week, we have October 18th, which is today, so you missed that. Tomorrow, here. Thursday, here. Friday, here. And every week, Wednesday, 5th period. Okay, and that's IPS 8. Okay, so sometimes these other ones will change. But this one is every Wednesday, 5th period, IPS 8. So that means that you can go and if you're having questions on any problems or how to use the site or whatever else, you can go and get help there. Okay? Okay. All right, so any questions about that? And the homework. So you have some that's due on October 22nd. Yes?
Can I come in second period instead of fourth?
Sorry, second period instead of fourth? Let's see. Yes. So if you want to come second period instead of fourth, because I have the same class, or the same makeup. I have another business math class, different students, and that's meeting second period. So if you prefer, you can do that, but we have to take special attendance. So you have to let me know when you come, because otherwise you won't get credit for coming. Okay, but if you want to come second period, that's okay. Yes? Yeah, it's Saturday. Okay? Not in general, just for the makeup class. Okay? Anybody have any other questions? Okay, so you have homework, coordinate plane, this, functions and models. Okay? And when we have a quiz in class, unless it's the Khan Academy stuff, then the quiz will be on the homework that was due before that class. Okay? All right? Anything else? Okay, so let's start. Okay, so functions and applications. I'm going to skip through, there's actually 4 PowerPoints. I'm going to skip through this one very quickly, because I think we did this already. But let's talk about it. Okay. stop me if you have a question at any point. So this is like you did in homework, right? This is a kind of definition of a function. So this is the x value and this is the y value. Okay, so when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 5.5. Okay, that's the kind of definition of a function. It's given as a table, but it's the definition of a function. Okay, and here they call it n of t. So this is a picture. So it means you put t into n and you get something out. And that's the general idea of a function, right? Put t in to the function, get something out. And the thing that you put in is usually referred to as the independent variable. And the thing that you get out is usually referred to as the dependent variable. Okay, so here, what's the independent variable? What? T, right? T is what the independent is what you put in. So what are we putting in? T, and what are we getting out? N of t. It's read n of t usually. So we would say that n of t is the dependent variable. That's a little bit wrong because it should be a variable, but it's not a variable, this is a function. But anyway, just the thing that you get out is the dependent variable. Okay? So let's not get confused. Okay, here. So one way to explain a particular function is to give a table like this. So this table tells me that when I put 6 in, I get what out? 450. It tells me that when I put 5 in, I get what out? 150. So one way to explain a function is to give it like this. Okay, but another way, another common way, is this. So this tells me that what? When I put 6 in, I get what out? 450. Get out. How do you find out what you get out when you look at the picture? So how do I know what I get out when I look at the picture? So if I put 6 in, what do I get out? 450. So what tells me what I get out? The height of the point, right? Okay, when I put 5 in, what do I get out? 150. So what tells me what I get out? The height, right? So that's how we know about this function. That's how we know the behavior of this function. What about when I put 4 in, what do I get out? 50, right? Okay? So we have different ways to explain our function. We can say, when I put 6 in, I get 450 out. We can say, when I put 5 in, I get 150 out. But a picture basically explains the same information, right? So we can say the picture also defines the function. Okay, is everybody happy with that? Now, they use words like this, real valued function. What does that mean? When they say real valued, they mean that the output is a real number. Okay, so basically, everything that we deal with in this class, the output is going to be a real number. So, and in that case, they call it a real valued function, because the value of the output is real, a real number. Okay? We talked about independent and dependent. So the independent is what? What goes into the function, and the dependent is what? What goes out, what comes out. Right? Okay? I'm just going through this quickly. It's all the same stuff. Okay, we also talked about this last time. The vertical line test. What does that mean? So, in these pictures, some of these are functions, but some of these are not functions. We said that we can look at a picture and figure out how the function behaves, right? So what do I mean by that? I mean like here. If I put in this value for x, right, then how do I know what the output is. I look at the height, right? So if I knew the height here, whatever it was, then I would know how this function behaves when at this particular value for x, right? Okay? So we said that we can describe a function by just putting the picture of it. So, okay, so a bunch of pictures here, so we can know about these functions, except, what? Some of these are actually not what we call functions. So just because it's a picture doesn't mean it's a function. So, okay, so all functions can be pictured, but not all pictures are functions. Okay? What do I mean by that? This one is not a function. Why? Because suppose I want to know what the value of this function is here. What would your answer be? Well, we just said, if you want to know the value, what do? You look at the height, right? Right? So how about here? I want to know the value at this point. So what do I have to do? I have to look at the height, right? But there are two heights. So there's not a single answer. We don't want that situation. Okay, we don't want to say there's two answers. For this input, I don't want to get two possible outputs. Okay, so we say this is not called a function. If you get two possible outputs, we don't want to call that a function. Okay? So what's the rule then? It's called this rule. The vertical line test. What does that mean? Well, if I can make a vertical line and cross the graph in two places, that causes a problem, right? Why? Suppose I draw a vertical line here, I cut it in two places. Why is that a problem? I just said I don't want two possible answers, right? But if you cut it in two places, it means that at that particular place, you're going to get two answers, right? So, if a graph, if you can cut it with a vertical line in two places, it means you're going to get two answers, and we don't call that a function. Okay, so this is not a function, this is not a function. How about this one? It's not a function, right? For example, here, I drop a vertical line, I cut it in three places. That's even worse. Okay, so that's called the vertical line test for whether a picture or graph is a function or not. Now these two, how about these two? There's no place where I can put a vertical line and cut it twice. Right? So therefore these are functions. Okay? So what's this referred to as? What's it referred to as? This whole concept? The vertical line test. It tests whether a picture is a function. Okay? Okay. So how about these? This one. Is that a function? What do you think? Yeah, right? There's no vertical line where you can cut it twice. How about this one? Yes. How about this one? Yes. How about this one? Yeah. Okay, so these are all functions. They're all different functions. Right? For example, if I want to know at 2, what's the value of this function, I have to go up to 2 and know the height of that. Now here, we not only have the picture, we have the formula, so I can tell you at 2 what the height is, even though I can't see it here. What is it at 2? When x equals 2, what's the value of the function? The value means the height, but we can't read the height, but we can read it from the formula. So what is it? What is it? I just got 0, but that's wrong. Oh, it is right. It's right. At 2, don't you get 0? 0. Minus 8 plus 4 plus 4, yeah. Right? So it's 0. Okay? Which is, I guess, what they meant by this 2 here. This 2 is here. Okay? Not here. I sort of did it there, but it's not there. It's actually here. Okay? So, this is, of course, another way to define a function. So we can do it with a table, like this. We can define a function like that. Define a function means give the information about the function. We can give a graph that also gives information about the function. Or we can use what? A formula that also tells you the output for a given input. So what is the independent variable here? That means the input variable. X. And what is the dependent variable? That means the output variable. Y. Okay? The independent variable is X, and the dependent variable is Y. Okay? Any questions? So this is just like getting our language straight. Right? Right? We want to know how to, be able to be conversational about this concept of functions. Okay, there's not a lot of complicated equations here or solving equations. So it's just getting the language straight. Okay? Another one. Here's a more complicated function. Has a power of 6 in it. Okay? And so on. So they give different names for different kinds of functions. So notice, just to bring this up now, this is, can you read this? How do I read this? The whole thing. Y equals 2 to the x. By the way, how do you say that in Japanese? It's the opposite. They read it x no nijo. Isn't that right? I'm wrong.
It's the opposite. X.
Oh, I got it wrong. Sorry. What is it? Ni no x? I made a mistake. I thought it was the other way around. It's been a while since I did it. But I thought it was x no nijo, but it's wrong. What is it?
That's x squared.
What is it?
X squared means x no nijo.
X no nijo. Oh, you're right. Oh, sorry. You're right. Yeah, I'm sorry. X squared means x no nijo, so it's the opposite. I was right. Okay, but this one is what?
2の x 乗
Ni no what?
x 乗
Ni no x jo. Yeah, so it's like the opposite in terms of order, right? Because I would say this is 2 to the x, but in Japanese you say x no. Now, what do you say? Sorry.
2の x 乗
Oh, okay, maybe I'm wrong. Anyway, fortunately, this isn't Japanese class. Otherwise, you guys would be in trouble because you'd have a lousy teacher. Anyway, all right, but anyway, so how do you read it in English? Y equals 2 to the x, right? Now, how do you read this one? This one. Y equals x to the 2, or x squared, but x to the 2, right? So this is y equals x to the 2, and the other one was what? Y equals 2 to the x, right? So they look almost the same, right? Don't they? I mean, if you're not paying attention, they look kind of the same, right? That and that. If you're not paying attention, it kind of looks the same, right?